All right, thank you, Corey. Thank you, Michael, and everyone for having me today. As you mentioned, I'm Hadi Kamali, just joined UCF as an assistant professor, EC department this semester, also a joint appointment with cybersecurity and privacy cluster. Since 2017, as a PhD student at George Mason University, I was working on the domain of microelectronic and hardware security. At that moment, it was more like around the topics like IP protection techniques, such as anti-Trojan techniques, hardware obfuscation techniques, watermarking techniques, and so on and so forth. Then after graduation from George Mason since 2021, I joined University of Florida as a postdoc, and I extended my research more towards other topics of microelectronic security, such as electronic design automation for security, applied machine learning for security, and security of heterogeneous integration. I've been contributing to so many funded projects by different agencies such as NSF, SRC, DARPA, and so on and so forth. So far led to more than 50 publications, 7 best paper here and there, 2 books, few book chapters, and patent, and so far around 2 million funded, in which my share was 235K. We're talking about microelectronic security, so not a bad idea to give an introduction about what microelectronic security means. So when you're talking about microelectronic security, the most important thing is this IC supply chain that we're illustrating here. So IC supply chain means that from the start, design specification to RTL generation, system generation, hardware, synthesis, building the physical implementation of your design, and sending out your design for fabrication, having your IC wafer, packaging, testing, and then your chip, your digital chip is ready to be released into the market. So the important point here is that every step throughout this process is super complicated these days. So almost every company is here and there all around the world doing many of the steps outsourced. Multiple reasons for that. For example, reducing time to market, being competitive with other companies, reducing cost, risk, getting the benefit from the best technologies, best expert around the world. But the point is that although all of them are under contract, there is no reciprocal trustworthiness between the entities that you're working with. So if I want to give you an example, let's say the rogue employees here and there for motivated reasons doing some nefarious actions. So you don't like them. And the outcome of such actions are security concerns and threats, such as the possibility of reverse engineering your design, the possibility of overproduction of your chip, the possibility of pirating your IP and your technology. So that's where security means to us for the digital design. At the same time, due to different reasons, one of them Moore's law, having more transistors inside one single chip, we see that modern chips getting complex and more, bigger day to day. So, for example, I showed one of them here. You have processors, you have so many peripherals, you have so many cryptographic and computation units. As a designer and as a chip manufacturer, you're not going to do this all by yourself from scratch. You rely to people that provide those IPs for you, and then you're reusing them, you're purchasing them from them. But the point is that increasing the reuse results in increasing the number of threats inside your chip, because you don't know what's happening inside those IPs. You don't know how you can trust them in communication between IPs. Some challenges came up. So over the years, as a consequence, you see that also the US spending in the domain of cybersecurity also increasing. So many solutions as countermeasures here to combat these security issues. I'm going to mention some of them that I'm focusing on, and I'm going to work on them for longer term here at UCF as well. One of them is the domain of protection techniques for your digital design, and specifically hardware obfuscation or logic locking. Logic locking means that you lock your design in a digital way. So you add something on top of your design, like additional information, additional key, additional input, making your design functional. Only those additional information is provided, and you don't share those information with anyone outside of your domain, outside of your design house, until everything is done. So that's a process which is like happening these days for the logic locking, and it can be done at any layer of abstraction, from high level such as RTL, hardware design descriptions, to gate level, even transistor level, even layer layout level. So that's very promising. But the issue is that over the years, we saw a lot of issues with logic locking techniques, back and forth between the definition of defenses and the attacks possible on top of them. So there's like a term of cat and mouse game between the defenses and attacks in the domain of IP protection. Throughout this project, which is actually multiple project funded over the years through through different agencies, we try to define a new type of logic locking and hardware obfuscation in digital aspects. So for example, we're using reconfigurability for logic locking in order to increase the sustainability for your digital design. So for example, if you use some form of reconfigurable logic, as an example, I put it here, which is lookup tables, basic building blocks of FPGAs these days, you can reconfigure them, you can repurpose them runtime. So it means that, for example, if you notice of some form of attacks, runtime, if you can do some action, you can reconfigure them and you can avoid some of these actions. So by using such approaches over the years, we try to see that, for example, what kind of strategies we can use this reconfigurability for our logic, what kind of replacement, what kind of relocation techniques we can use, what kind of insertion policies we can use. And over the years, it advanced more. And now we're working on the fact that how we can use emerging technologies. For example, we always focus for digital design on CMOS technology, but how we can use non-CMOS technologies for using this purpose, for having this purpose of like reconfigurability for your design when everything is done, because emerging technologies provide so many features such as bringing cost so much lower for implementing this reconfigurability. So this reconfigurability and these emerging technologies can help us to move forward this topic. Second project that I would like to mention, and I just like last year I was working on this domain, is the post-chips system in package security. So over the years, we witnessed that the domain of digital design getting more towards 2.5D and 3D architectures, relying on advanced packaging because of the fact that we see that the number of transistors included inside a single chip is not getting and not following the Moore's law, showing that, for example, it can be increased over the year. So we're on the cap that we cannot have bigger 2D ICs. So we're going to put ICs on top of each other, stacked in a 3D or 2.5D architecture using advanced packaging. So in this case, instead of dealing with one chip, you're dealing with multiple chips known as chiplets. And these chiplets come from here and there, different entities, different parties involved there. So the surface of people that you're working with them is getting even worse from the security perspective. If you were dealing with 10 parties in 2D architecture, now you're dealing with 100 parties for building your whole package, including multiple chiplets. So possibility of untrusted chiplet, possibility of malicious hardware, so many glitching possibility and attacks. So many solutions should be, so many mitigation techniques should be considered. Then I listed two of them that we were working on them back to UF, and now I'm going to transfer some of them here in UCF as well. For example, the domain that I mentioned, hardware obfuscation, IP protection technique, how we can bring this between layers, like for example, between chiplets and the package, more towards physical implementation and building correlation between the hardware design and the package architecture. On the other side, one thing which is more tangible here is the importance of physical attributes. For example, how we can use SEM images, scanning electron microscope images of the chips that we're fabricating to see that are those designs providing exactly authorized action we were looking for. So it's a comparison between like the prefabrication, post-fabrication in a based on the physical attributes. And you see that, for example, there is no form of like malicious hardware or hardware Trojan inserted in your design. This is just a two simple example. So many more mitigation techniques, so many more solutions, even coming from 2D to this 2.5D and 3D architecture should be revisited again, making sure that those solutions can be migrated here as well. Going super fast on two new upcoming direction here as well, which is more about verification of the hardware that you build. So we're working on formal verification tool, but formal verification tool is like built for the purpose of like IP level verification, IP level validation, and it's for like more functionality perspective of the design. Now the question is that when we have like such kind of big SoCs, big system on chips with lots of IPs in it, is there any way we use this formal based verification tools for verifying the security properties on top of your design, making sure that every connection is fine, make sure that there is no form of like confidentiality, integrity issue, no information leakage, and so on and so forth. So in this project, we're working on the fact that how we can generate such kind of security properties at the system level to make sure that, for example, the security rules in your design is also verified. The second project I would like to mention is about the usage of large language models for the hardware security. Everyone these days, I believe, using LLMs, large language models such as GPT, Google Bard, and everything, doing automation for you. One of the applications definitely would be domain of hardware and also hardware security. For example, LLM can give us a good representation of a hardware design if we give a good prompt to those tools. Also, it can help us to generate the assertion and security properties we're looking for, like the example I gave you in the left side of this slide for verification of the security. So these large language models can be used very well for the domain of hardware and also security, and I already started this project as well here. Probably throughout my presentation, you heard some keywords related to some part of the hardware and microelectronics security. For example, if you're working on AI and ML and their application, you probably saw that LLM is a good application for the hardware security. And so many classifiers we're using for hardware security, for verification, for validation. So that's a very good connection. Some part of the work that we're doing is related to the compiling points and computer architecture, electronic design automation, how we can secure those tools, making sure that the tool that we're using through the IC supply chain, considering the security as well. Cryptographic arithmetic is important. We're working on forward trust throughout IC supply chain. If we can provide forward trust, that's a really good and promising approach for providing security in IC supply chain. As I mentioned, emerging materials and devices like non-CMOS technologies that we can bring. Sustainability is another approach that we can mention, and the possibility of collaboration, and also advanced packaging and semiconductor for the post-chip project and post-chip application that we need to bring for the security of heterogeneous integration is another item that I would like to bring up for the point of the collaboration. I would like to thank everyone from the collaborators that I was working with them and going to work with them in the future as supporters from different agencies. And thanks a lot for having me today. I'm happy to answer your questions.